Okay, now I'm going to generate some of the simplest patches that you can make for the brain seed. We'll start with the actual simplest patch, which is just random generation. When the brain seed has nothing input into the CV input and record is active and you receive a clock, it will automatically generate a 0 to 5 volt random output here. So I'm going to begin by generating clock from just turning on the maths on this side to cycle. And you can see that little blip. And then I'm going to take that output and plug it into the cycle input. And you can see that I'm getting clock, even though this is not a regular clock signal. I'm not using the square output. And the reason why is that all of the digital inputs on the brain seed have comparators, so they can work with basically any type of cyclic signal that has a 1.5 volt crossing. And I have reseed active, it's blinking red, and I'm generating some random 0 to 5 volt voltages over here. So we plug the main output of the brain seed into the volt per octave input of this Meleco oscillator that's off of screen, and the trigger out of the brain seed into the other side of the maths. So this is creating a little blip, a little trigger every time we're getting a new step, which is now triggering this side of the maths. And I'm going to use that output to open the Borg filter over here. The Borg is in low pass gate mode, so it'll make some really nice blippy sounds for us. I also off screen have an oscillator plugged into the phase modulation of the Meleco Richter oscillator just to provide a little more interesting sound. I'm going to take the triangle output and plug it into the Borg. So you can hear some nice random tones happening there. You can speed up the clock. And turn it down, and we can speed it up quite a bit. The brain seed can go very fast. Up to the point where it starts to sound like digital noise when it's plugged into something like an oscillator. So I'm going to turn off clock, and we'll do the next patch, which is basically just adding one more cable. So I'm going to grab one of the offsets from the maths. These middle knobs on the maths, when you have nothing plugged into them, create -5 to +5, about a little bit less than that, voltage outputs. So I'm going to use one of the outputs from one of these and plug it into the seed input of the brain seed. So what I'm going to do is turn the clock back on and then turn on recording and turn this knob. And you'll hear the voltage change the pitch of the oscillator. And then when I turn off the reseed, you'll hear it loop, basically. I'm in variable length mode, so you will get a loop of whatever length of knob turning I do while the reseed is active. Okay, so I'm going to turn on the clock. And I'll start by turning off the reseed since we had it on, and turn it back on. And you can hear my sequence looping there. And if I want to, I can go ahead and turn on quantizer, make sure it's snapping to semitones. And we'll do a few more of those just because it's fun. What's not fun about that? Nothing. Everything's fun about that. Anyway, all right, so there we have random generation by not using anything in the seed input and using a clock. Random generation itself, I should point out, is cool because you can use the brain seed as sort of a semi-random generator, and that's the next thing we'll do. So I'm going to go ahead and hit the clock back on again, and I will turn on record. So we're now generating those random voltages, And I'm going to clock divide the clock out from the maths. And then what I'm going to do is take one of these division outputs from this gate clock divider and plug it into the reseed input. And what will happen is that when the gate coming out of this reseed is high, it's going to flip the record state of the brain seed. So we'll get a recording half the time and a playback the other half of the time, which should potentially create some sort of evolving random. So here we go. There we go. I had it in trigger mode. So you can see this little light turning red, then turning green. It's flipping back between play and record states. So it's almost like this stair step of random. If I want to get a little bit goofier than that even, since all of these inputs are comparators, in theory, I should be able to grab an output from this noise generator, this noisy, and attenuate it. And basically how hot it is coming in determines whether or not this is going to be recording or not recording. So let's try that out. I'm going to hit the clock on. So as I adjust the threshold up and down, I'm getting different triggerings of recording on and off based off of the level of this white noise going through this attenuator. So there you get random. So that's a pretty cool trick to do with the brain seed. Random itself is a lot of fun. Like even just the basic patch of it, I use a lot. For, I've got it in variable mode now, and I'm working on a patch, and I just need to make a sequence. And so very often, I'll hear something like that I like, and I'll just keep it. Or, just keep doing this over and over again and get some cool little sequences. Just like that. And then, of course, we've got the shift input. So once you've got a little sequence like that going, you can shift it externally. I'm just going to use the other offset knob and do a shift. To the left on this knob, since it's bipolar, is actually a negative shift. And those are the basic functions of the brain seed, just using it as a CV recorder or as a random generator. Next, I'll go through using it with an external sequencer.